Suggestions will filter as you type. 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 700x. Configure Azure Application Gateway. 19 minutes. Module. 6 units. Intermediate. Administrator. Azure VPN Gateway. Learn how to configure Azure Application Gateway. Learning objectives. In this module, you learn how to identify features and usage cases for Azure Application Gateway, implement an Azure Application Gateway, including selecting a routing method, configure gateway components, such as listeners, health probes, and routing rules. Prerequisites. None. This introduction. Introduction. Completed 100 XP. 2 minutes. Azure Application Gateway is a load balancer for web traffic. Administrators implement an application gateway to manage traffic to their web apps. Suppose you work for the motor vehicle department of a governmental organization. The department runs several public websites that enable drivers to register their vehicles and renew their licenses online. The vehicle registration website has been running on a single server and has suffered multiple outages because of server failures. The outages have resulted in frustrated drivers trying to register their vehicles before their registrations expire. You're responsible for improving the resiliency of the site by adding multiple web servers to distribute the load. You want to centralize the site on a single load balancing service and simplify the URLs for site visitors. You're researching how to implement Azure Application Gateway. Learning objectives. In this module, you learn how to identify features and usage cases for Azure Application Gateway, implement an Azure Application Gateway, including selecting a routing method, configure gateway components, such as listeners, health probes, and routing rules. Skills measured. The content in the module helps you prepare for exam AZ 104. Implement Azure Application Gateway. Completed 100 XP. 3 minutes. Administrators use Azure Application Gateway to manage requests from client applications to their web apps. An application gateway listens for incoming traffic to web apps and checks for messages sent via protocols like HTTP. Gateway rules direct the traffic to resources in a back-end pool. Business scenario. Consider a scenario where internet client applications request access to resources in a load-balanced back-end pool. The requests can be managed by implementing Azure Application Gateway to listen for HTTP's messages. Messages can be handled by load balancing rules to direct client request traffic to the appropriate resources in the pool. The following diagram illustrates this scenario. Things to know about Azure Application Gateway. Let's examine some of the benefits of using Azure Application Gateway to manage internet traffic to your web applications. Expand table. Benefit description. Application layer routing. Use application layer routing to direct traffic to a back-end pool of web servers based on the URL of a request. The back-end pool can include Azure Virtual Machines, Azure Virtual Machine Scale Sets, Azure App Service, and even on-premises servers. Round-robin load balancing. Employ round-robin load balancing to distribute incoming traffic across multiple servers. Send load balance requests to the servers in each back-end pool. Client requests are forwarded in a cycle through a group of servers to create an effective balance for the server load. Session stickiness. Apply session stickiness to your application gateway to ensure client requests in the same session are routed to the same back-end server. Supported protocols. Build an application gateway to support the HTTP, HTTPS, HTTP/2, or WebSocket protocols. Firewall protection. Implement a web application firewall to protect against web application vulnerabilities. Encryption. Support end-to-end request encryption for your web applications. Load autoscaling. Dynamically adjust capacity as your web traffic load changes. Need help? See our troubleshooting guide or provide specific feedback by reporting an issue. Determine Azure Application Gateway routing. Completed 100 XP. 4 minutes. Clients send requests to your web apps by specifying the IP address or DNS name of your application gateway. Your gateway directs the request to a selected web server in your backend pool according to a set of rules. You define the rules for your gateway to identify the allowable routes for the request traffic. Things to know about traffic routing. Let's take a closer look at your routing options for Azure Application Gateway. Azure Application Gateway offers two primary methods for routing traffic. Path-based routing sends requests with different URL paths to different pools of backend servers. Multi-site routing configures more than one web application on the same application gateway instance. You can configure your application gateway to redirect traffic. Application gateway can redirect traffic received at one listener to another listener, or to an external site. This approach is commonly used by web apps to automatically redirect HTTP requests to communicate via HTTPS. The redirection ensures all communication between your web app and clients occurs over an encrypted path. You can implement application gateway to rewrite HTTP headers. HTTP headers allow the client and server to pass parameter information with the request or the response. In this scenario, you can translate URLs or query string parameters, and modify request and response headers. Add conditions to ensure URLs or headers are rewritten only for certain conditions. Application Gateway allows you to create custom error pages instead of displaying default error pages. You can use your own branding and layout by using a custom error page. Path-based routing. You can implement path-based routing to direct requests for specific URL paths to the appropriate backend pool. Consider a scenario where your web app receives requests for videos or images. You can use path-based routing to direct requests for the /video/path to a backend pool of servers that are optimized to handle video streaming. Image requests for the /images/path can be directed to a pool of servers that handle image retrieval. The following illustration demonstrates this routing method. Multi-site routing. When you need to support multiple web apps on the same application gateway instance, multi-site routing is the best option. Multi-site configurations are useful for supporting multi-tenant applications, where each tenant has its own set of virtual machines or other resources hosting a web application. In this configuration, you register multiple DNS names, CNAMEs, for the IP address of your application gateway and specify the name of each site. Application Gateway uses separate listeners to wait for requests for each site. Each listener passes the request to a different rule, which can route the request to servers in a different backend pool. Consider a scenario where you need to support traffic to two sites on the same gateway. You can direct all requests for the http://contaso.com site to servers in one backend pool, and requests for the http://fabricam.com site to another backend pool. The following illustration demonstrates this routing method. Need help? See our troubleshooting guide or provide specific feedback by reporting an issue. Configure Azure Application Gateway components. Completed 100 XP. 5 minutes. Azure Application Gateway has a series of components that combine to route requests to a pool of web servers and to check the health of these web servers. These components include the front-end IP address, back-end pools, routing rules, health probes, and listeners. As an option, the gateway can also implement a firewall. Things to know about Application Gateway components. Let's explore how the components of an application gateway work together. The front-end IP address receives the client requests. An optional web application firewall checks incoming traffic for common threats before the requests reach the listeners. One or more listeners receive the traffic and route the request to the backend pool. Routing rules define how to analyze the request to direct the request to the appropriate backend pool. A backend pool contains web servers for resources like virtual machines or virtual machine scale sets. Each pool has a load balancer to distribute the workload across the resources. Health probes determine which backend pool servers are available for load balancing. The following flowchart demonstrates how the application gateway components work together to direct traffic requests between the front-end and back-end pools in your configuration. Front-end IP address. Client requests are received through your front-end IP address. Your application gateway can have a public or private IP address, or both. You can have only one public IP address and only one private IP address. Web Application Firewall, optional. You can enable Azure Web Application Firewall for Azure Application Gateway to handle incoming requests before they reach your listener. The firewall checks each request for threats based on the Open Web Application Security Project, OWASP. Common threats include SQL injection, cross-site scripting, command injection, HTTP request smuggling and response splitting, and remote file inclusion. Other threats can come from bots, crawlers, scanners, and HTTP protocol violations and anomalies. OWASP defines a set of generic rules for detecting attacks. These rules are referred to as the core rule set, CRS. The rule sets are under continuous review as attacks evolve in sophistication. Azure Web Application Firewall supports two rule sets, CRS 2.2.9 and CRS 3.0. CRS 3.0 is the default and more recent of these rule sets. If necessary, you can opt to select only specific rules in a rule set to target certain threats. Additionally, you can customize the firewall to specify which elements in a request to examine, and limit the size of messages to prevent massive uploads from overwhelming your servers. Listeners accept traffic arriving on a specified combination of protocol, port, host, and IP address. Each listener routes requests to a back-end pool of servers according to your routing rules. A listener can be basic or multi-site. A basic listener only routes a request based on the path in the URL. A multi-site listener can also route requests by using the hostname element of the URL. Listeners also handle TLS/SSL certificates for securing your application between the user and application gateway. Routing rules. A routing rule binds your listeners to the back-end pools. A rule specifies how to interpret the hostname and path elements in the URL of a request, and then direct the request to the appropriate back-end pool. A routing rule also has an associated set of HTTP settings. These HTTP settings indicate whether, and how, traffic is encrypted between application gateway and the back-end servers. Other configuration information includes protocol, session stickiness, connection draining, request timeout period, and health probes. Back-end pools. A back-end pool references a collection of web servers. You provide the IP address of each web server and the port on which it listens for requests when configuring the pool. Each pool can specify a fixed set of virtual machines, virtual machine scale sets, an app hosted by Azure App Services, or a collection of on-premises servers. Each back-end pool has an associated load balancer that distributes work across the pool. Health probes. Health probes determine which servers in your back-end pool are available for load balancing. Application Gateway uses a health probe to send a request to a server. When the server returns an HTTP response with a status code between 200 and 399, the server is considered healthy. If you don't configure a health probe, Application Gateway creates a default probe that waits for 30 seconds before identifying a server as unavailable, unhealthy. Need help? See our troubleshooting guide or provide specific feedback by reporting an issue. Feedback. Was this